Well, hello, friends. Today we are going to hack on the browser once again, because it's been a while. And I feel like I always say that about something, but I guess it's always been a while since we did something. So, gotta have a good rotation. So, today I think we're going to do nth-child and maybe nth-of-type selectors. So, if you're not familiar, they are CSS selectors that allow you to select, for instance, like every second child of a certain type. So you can say like every second child that's type div, and you can do every third. You can do these repeating patterns and stuff, and it's a pretty neat thing. Let's go and look up the syntax for it. Syntax. I guess we can just go straight to MDN like always. They have the sweet documentation. So this syntax picks the second li element in a list. So it's always like child of a specific parent. So this would be like the second li child of a common parent. And this here creates a cycle of repeating matches, so that if you have like 8 children, for example, then number 4 and number 8 would be selected by the selector. So, and then you have these shorthand keywords like odd and even. And then you can do this AN plus B notation, which means that you can do like 4n plus 1, then you get like every four children plus 1, then you get a match. So I guess odd, for example, I mean even is really like 2n, and odd is 2n plus 1. I think. Anyway, so let's just implement this stuff. And I think this here is this is how we're going to represent it in the data structure. So, or actually, let me grab an example here so that we have something we can work with. Start with this one. We'll just use their example. Those nice, lovely people who make MDN. nth-child. And we need the CSS as well, so we'll just put that up top. I'm just going to do a little bit of tidying up here. Style. There we go. Put this in the body. Look what good boys we are. Let's even put a doc type. That's the maximum good boy tag right there. All right, so let's open this here in Firefox and take a look. So now we have our little test, and we can actually see how far we would be able to get with this test currently. And I suspect that we are just going to choke in the parser. nth-child, HTML, death by parse. Right. So we're just hitting a CSS parser assertion failure. That's fine. So let's make this thing happen. Oh. Sorry, my phone was ringing there, but I'm not going to pick that up now. Okay. Blacking out. Okay. Let's go to the selector file here and define some new stuff. So this will definitely go in the selector class somewhere in the simple selector. Let's go look at the CSS that we borrowed here. So these are our things that we're working with. And oh, it's actually kind of a simple test. Nth child to n+1. Well, we can do this. So it's a pseudo class that's applied to this particular tag name selector here. So we will have to add it as a pseudo class, and we'll say like nth-child. And then we'll need to store this data with the selector. So we'll put it in a little enclave here, like nth data. We can call them maybe like cycle size or step size maybe. And offset, because that's what they are really. It's like step size is 2 and the offset is +1. And maybe they should be int actually, or step size isn't unsigned, but the offset, I think you can have negative offsets. I think. I guess we can try it out. What if you did this? Would it be all backwards? Doesn't seem to change anything. Well, what if we did 3 then? Just testing something. See if that makes any difference. Yes, it does. Okay, so cool. Then let's use an int for that. I can use an int for both, whatever. So now we gotta parse these. So CSS parser and parse. Where is this? Pseudoclass, where we parse a simple selector and extract the Pseudoclass. So we haven't been very good about this function notation pseudoclasses. The only one that we actually do anything with is not. And the only thing we do is we just try to ignore it by figuring out where the matching close paren is. So that if you do this, then the parser will just ignore everything here and keep going. So I guess this will be our first parse of something that's not just dummy value. Alright, let's just keep this open here so I can see what it looks like. So if next is nth-child. Oh, selector nth-child, and we also had nth of type, but I think maybe we can skip that one for now, and we can get to that one later. So nth-child, then first thing we want to do is we just want to, so this looks ahead in the parser. So we want to consume that many characters now. So consume specific, I guess we can just do this. We should have an overload that allows you to consume a whole string like that. Consume specific. String I, return true. Alright. One day I gotta make this thing actually able to fail. Right now it will just crash if it fails. But I've been taking the strategy of like not caring so much about writing a robust parser, but rather just parsing the stuff so that we can get them into data structures so that we can do the whole like CSS and DOM engine stuff. Because the parser can always be replaced later with something that fails more gracefully. But it's important to be able to start building the DOM and CSS engines. At least it's important to me because it's much more motivating instead of being stuck writing a CSS parser forever. So Where were we? Pseudoclass, right. Here we are, nth-child. And then we expect a open paren and a close paren eventually. Okay, and then I guess now comes either there's the odd even notation, so let's just get those out of the way. Next is odd. Then, wait, how did I define that thing? I just made a struct, but I never declared one. So let's do an nth data. All right. Simple selector dot nth data dot offset is 1 and step size is 2. Else if it's even, then step size 2, but the offset is 0. Else then is this case. So this is really kind of a crappy example actually, but it's perfectly possible to also do something more like this, right? We saw that before on MDN. So this just means child number 2. So there's no cycle, just an offset. Yeah, no cycle, just an offset. And in this case, if it's 2n, then there is just a, this is just a cycle, no offset. This is just an offset, no cycle. And this is a cycle with an offset. Okay, we can do that. I guess here we can just say Pseudoclass is nth simple selector. What the heck is the name of that thing? Simple selector Pseudoclass nth-child. All right. Maybe we can even do like parse nth data. Simple selector. Okay, and then we'll put that in a separate function. Also, I guess here we need to do some. Just initializing the nth data that we added to the struct. All right. We'll parse nth data. And we'll put him into selector, simple selector. Okay. And there we can actually return true. Return true. Okay, how did we call this? I already forgot. Search success. Slowly switching gears towards failing more gracefully by starting to return some failures, successes, but not doing much with them. It's a little bit cumbersome to switch from this like fail hard to fail soft style in a growing code base, but you gotta do what you gotta do. So here, now we want to parse. It's always going to be a number next. So I guess if is digit peak, if it's not something like that, then we can fail. Okay, and then we can do something like int consume number, and let's write a helper for that. maybe even like this, consume number, const, while is digit peak. Char. Oh. Make a little stack buffer here with 32 character slots. Buffer, say, and then we will just do something like buffer append consume 1. Okay, and then when we run out of digits, we'll just say return string copy buffer to int okay. I know, so we cheat again. Frickin' springtime coming. Okay. It's not perfect. It's not beautiful, but it'll do the trick, I think. So then, if peak, if we have an n coming up, then simple selector, nth data, then that's the step size that we just read. So that's the number. Else, if peak is, I guess, close paren, simple selector, nth data, offset is the number we just read. I guess those are the two possibilities. And actually, in that case, we can just return. So we can handle that first, and that's pretty good. Because now we can say if it's not n, then we will return false. Okay. So now we have our step size. And actually, in that case, we know that the step size is 0. So let's just write that out explicitly, even though it will be default initialized to 0 here. It's still good to write it out so that we know what we're doing. So step size is that, and then we will consume a specific n just to progress, and then now it's either a plus or a minus, I guess. Plus or minus, or it could also be a closed paren, in which case the offset is 0. So if peak is closed paren, simple selector, nth data, offset is 0, return true. Parse succeeded. If peak is plus, simple selector, nth data. Well, then we'll consume it. I guess, let's see, wait, hold up. And sign, let's do it this way. Else, if peak is minus, sign is -1, else return false. All right. Now we have a sign that we can use. Then we just need another number. So number is consume number. And then nth data offset is number times sign. Return true. And at this point, we should really be expecting to see a closed paren, but we can let the parent deal with that because we've done what we wanted to do. And we need to consume the sign character, actually. So there we go. All right, I think that's our nth parser. So maybe we should go ahead and figure out how to dump these. So we'll just write some dump code for it. We have code to dump style sheets, which dumps rules. And we don't really do that much for pseudo classes, but we can do that for nth data. So let's see, blah, 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 blah. Where's the simple selector? Oh, here, okay. I'll just put it here at the bottom. So if simple selector Pseudoclass is nth-child, then debug printf nth-child. I guess we can do nth-child and nth of type. Frick. Well, we're doing one at a time here, so we should actually get rid of this one just for the testing purposes, so that we don't crash. So if it's nth-child, then you will say d n plus d. Does that make sense? Actually, maybe C, something like that, and then we will do simple selector nth data, step size, simple selector nth data, offset is less than 0. If so, it's a minus, otherwise it's a plus. Simple selector nth data offset. And I guess we can abs it so that we don't get an extra minus. And since we are breaking the lines, let's do this. It's a bit more tidy. There we go. Alright, I feel like that's pretty good. Let's see if this can build and if this can run. Wouldn't that be nice? So of course, oh, we're missing some case. We didn't implement the selector matching yet. And that's what it's telling us, that we're not including that new Pseudoclass in this big switch statement here. Simple selector Pseudoclass nth-child. So we're just going to break here and ignore it for now, because I just want to see that we parse it correctly. And then if it parses correctly and we get like a valid looking style sheet, then we can go and implement the selector matching. Okay, maybe this should stop being always on top. And oh, we should make a link to this thing. nth-child HTML. Okay, well, this does not look right, but let's see what the style sheet dump says. Okay, so it appears that we have parsed these things kind of correctly. Let me just see that they match up to what we have in our document. So these two selectors here, kind of useless. Maybe we should optimize them out since they don't apply any style, but they turn out like this, right? So 0 step size plus 2 offset. And this one is 2n plus no offset. And then the rest of them are 2n plus 1. That's great. So what are we going to do with these? And I guess that everything becomes lime right now because what exactly? I guess maybe they're matching this thing right here. It's a completely empty selector. I guess that's just showing up because of the comma. It's kind of interesting. So if we didn't have the comma, we definitely shouldn't consider a completely empty selector to be matching everything. So it seems like we do, and that's definitely a bug that we need to fix. But it is a separate bug, so let me just take a note of that. Selector bug to fix. A completely empty selector should not match anything. Duh. Alright, so let's implement this selector then. So what we want to do here is we just want to figure out if we should reject the currently evaluated element. So selector matching is recursive. I know I've talked about this many times, how it works, but it's recursive from right to left. And at every step of the way, we evaluate if a specific simple selector component, which we have here, is a match for a given element. And we start here by looking at the pseudoclasses. And this is definitely, we're not writing this in the most optimal way, we're just writing it to implement the functionality, and then there will be plenty of time to make these things fast once more functionality is in place. So, element, we want to figure out if his child, if he matches the nth child specification in the selector. So, I guess what we really need for that is the element index in his parent. So something like that. If index in parent modulo the selector component nth data step size is equal to component nth data offset. If this is not true, then it's a rejection. Okay, because here we work by rejecting things. We look, I guess that's why the completely empty selector succeeds at matching everything. It's because we just fall all the way through here and discover, well, there was no reason to reject it, so it must be a match. But that clearly should not be the case. So now we just need to implement index in parent. So I guess maybe we should first check if it even has a parent, because if element parent, if it doesn't have a parent, then it cannot match an nth child selector, clearly. So that's a quick rejection right there. And then we will implement, we'll do this in, maybe even in tree node. So tree node is the tree abstraction class that we have in libHTML. So all the different trees inherit from tree node. It just provides like basic tree walking functionality, so we don't have to implement it over and over again. So we'll do something like size t index in parent. And let's just assert that we have a parent. And then you be a good boy and don't call this on something that you don't know to have a parent. So parent, first child. Node, and node is node next sibling. All right, that's pretty good. And then we'll just say if node equals this, return index, otherwise ++ index. And here we will say assert not reached, because by golly, you should definitely have some index in your parent. Now, clearly this is not fast, right? And you can imagine this slowing down things if you have a lot of nth child selectors or whatever. And you know, a common strategy that you might see to optimize this in a more sophisticated engine would be to cache the index and parent with the node, for example. And you can make that optional in the presence of selectors. But we're just going to compute it every time because it's okay. So, different signedness. Oh, index and parent. I guess if we are a little bit good boys here and just turn that into an int, that'll be okay. And don't come at me with your 2 billion sibling DOM, please, because then we will overflow. We should definitely put some limits on the DOM. I don't remember what they are usually, but there's usually like a depth limit and stuff like that that browsers put, and it might be standardized these days. It used to not be standardized, but these days they standardize everything and they're so good about it. And I keep forgetting to make a hyperlink here. That's a crash. All right, so why did we crash? Pray tell. Selector engine matches is crashing. Divide error. Wow. Oh. Are we trying to divide by 0? That's very silly, isn't it? Clearly we can't do that. So we should probably sophistikize this a little bit. How do we write this in the most natural way? See, I don't like doing these, but I think maybe we'll just do them because they look so goofy. Braces, but I don't want to compute the index and parent more than once, so element index and parent. We'll type out a cast, and then we can say tap tap tap. So if index and parent is no, that's not what I want to do. If component nth data step size is 0, if component nth data offset, if index in parent is not the offset, then return false. Otherwise, so we can divide by it. Okay, then we have a step size, and then we have to be this offset into the current step. Divide by 0 bugs. You don't get those every day. And I still haven't made a frickin' hyperlink. Okay, so this does not feel like it has succeeded very well, and clearly the layout of these guys is wrong, but we can start to at least investigate what's going on here. So let's just see what this DOM looks like. These are inline block. Yeah, we don't support display inline block yet. We do have display inline. Oh, I have to sneeze. Jesus. Excuse me. So let's just tweak this a little bit. I just want to see what it looks like if we just change them to inline. Ploop, look at that. Adorable. But why are we matching all of these guys? That's what I want to know. So let's see, debug. Let's just debug what we're doing here. So checking if index in parent is not equal to offset component inf data offset and step size is equal to offset. Wait. This is written in such a weird way. Okay. I just want to see if we're running these selectors, and I still forget to do the thing. Okay, so what exactly are we working with here? Tree. I wonder if this will work now. Oh shit! Yeah, we can see the style that's applied down here. How nice is that? But we can't see which selectors were matched. But at least it's kind of neat that we can see the style that the element has. Would be nice if it would highlight it better, because it does some highlighting, but it seems like the highlight is not painted the very last. Maybe we should make it highlight the very last somehow. Anyway, so let's look at the DOM here. So what we want to be seeing is 2m plus 1, which is every odd element. So 1, 3, 5, and 7, every odd one. Let's see, nth-child 3 is used in the counting because it is a child, but it isn't selected because it's not a span. Yeah, that makes sense. So the selector specifies span, right? Span with nth-child. And then these guys, they all have an index and parent. So we can probably simplify this by simplifying our document. It's too much document. Let's start by linking ourselves to a test page, and let's make our own test page for this because this one is too big. Some non-depth. Okay, so time to simplify. Don't need you guys. Don't need these guys. We only need this guy right here. So if we only have this, and then we can also get rid of 2 of these guys, or maybe even only keep these 3. Okay, so this should give us a easier thing to work with. Okay. It should look like this. Okay, so why does the middle one match? Checking if index and parent. So a key. Why is index and parent 5? Who has 5? Oh shit. Oh, I see what it is. Right. So I'm forgetting about text nodes. So CSS doesn't care about text nodes, but I'll show you. Because I did this at the tree node level and not at the element level, then we are also getting text nodes. And if we look at the DOM here, then we will see that, I feel like I've shown this problem before, but I always forget about it again. So we see 1, 2, 3, 4, 5, 6, 7. These are all of the children from the node perspective, even though these here are just text nodes. This is actually just a white space containing text node in between the spans. And then here is a text node inside the span with the text. CSS only cares about elements, so we have to do this at a higher level. So let's move up to element and do it there. So we can even say index and parent, or even element index and parent, just to make it super clear that we are working with elements. So parent first, do we have first element child? Is that a thing? Do we have next element sibling? Is that a thing? It's sort of a thing on Node. There's no first element child. We should have that. Let's invent it. First element child. So it will go like this. First element child. Starting with the first child and going to next element sibling. Actually, we can just do next sibling, doesn't matter. But the moment we hit an element, we will return it. Cool. So now we have first element child, which means we can use it like this. And this returns element, right? Yeah, so we can actually call this element. And we'll do next element sibling to make sure we skip over text nodes. And let's try again. Index in parent. Forgot to update that name. All right. Bloop. Okay. This is sort of the opposite of what I expected. I guess that it's literally the opposite. So I guess that these are probably 1 based. 0. These are, yeah, they're clearly 1 based, not 0 based. So we just have to consider that. Maybe the easiest thing is just do a +1 on the index and parent. Oops. And we can get rid of all the logging also. I think we should be good with that. Alright, so now let's check the MDN version. And it's looking just right. I mean, as far as matching these guys goes anyway. but we didn't implement nth type. We'll get to that one. So let's see. We can add nth-child, add welcome, diff. Do we have any big chunky changes? I should calm down with this stuff. Let's see. Because I want to add the element helper first, I think, because that one is kind of separate. Element h. Oh no, wait, that was node. H. Frick. Lib.html, add node, first element child. Okay, and then git add lib.html, add element index in parent. Is not cached. Note that this is not cached, but will traverse parents' children each time it's called. Every time it's called. All right. Okay, and then you just have the nth stuff left. So let's add it. Okay, so I'm on dub. I didn't want the MDN one just yet. So lib.html, implement nth-child. The nth-child Pseudoclass. It's now possible to select. Well, we don't have to explain what it does, but it's nice. What can we say about it? This is not optimized for performance, and we'll run some simple selector engine reordering will be needed. That'd be a good idea after this. So let's do nth type. So nth type is basically the same as nth child, except that it also has to match. It doesn't just count the index into the parent, but it counts the index of a specific type of element. So it will not just ignore text nodes, but it will ignore anything except a specific tag. So the way that we would implement that is element index in parent of type, or with tag name, I guess, element tag name, or element index in parent of type element same type in parent. But that sounds like parent of same type. Element index of same type in parent. Weird name, but okay. Same type. And then this will instead be, if element is this, then return index. And we will only increment index if element tag name is my tag name. Okay, and if we don't find ourselves, we should still assert. So that's good. So let's add nth type. And CSS parser, please. So nth-child, we will do, put him right after here. Oh, wait, why did this end up so messy? I just want to do that. Poof. It's not so bad. Nth of type. Okay, and then we parse that into an nth of type Pseudoclass, and the nth data parsing is just the same. So I think this will be pretty straightforward to do this one. So we'll just put this guy back here and sync. And we'll go to the MDN one, and we died. Shit. Why did we die? If next is nth of type. Wait, did I even rebuild there? I did not rebuild. What was I expecting? So this could probably be slimmed down and simplified in some ways, but I think it's still pretty good. Gotta make sure we dump this correctly as well. So, could be a little sloppy here. It's not the end of the world. So this one is good, and MDN. This does not feel super correct. But maybe we just screwed it up somehow. Okay, how did I screw this up? I don't remember what edits I was making. And oh, it's the comma is missing. So see, no comma, it becomes a descendant selector. Silently. And sync and run. Let's just see that it looks right here. Okay, so this is the result that we want to get. nth-child, Madonna. Okay, so as we can see here in the indexing, this is 1, 3, 5, and 7, so the EM is included, whereas down here, this is 1, 3, 5, and 7, so the EM is not included in the count when we're using nth of type. Great. So I think maybe we will import the nth of type test here. nth-child and nth of type test. Let's say. Yeah, that's lovely. So base homonon, nth-child. We'll call it. I want to rename that one to nth-child, nth of type. Okay, HTML. Support. Oh no, dang it! How did I write the previous one? Implement the nth-child Pseudoclass. Implement the nth of type Pseudoclass. This was very easy since it can just piggyback on the mechanisms used by nth child. Okay. Great. So, I think we are probably going to be done for the day here. So, this will be the end of the video. If you made it this far, then I thank you for watching and for hanging out with me again as we dive into browser hacking. Hope you enjoy the variety on the channel. I certainly do. And I hope you saw something interesting here today. Yeah. It's nice that we're still going, isn't it? And let's keep going. See where we can take this. Anyway, thanks for hanging out. We'll see you next time. Bye.